Hey, fellow problem solvers, Colfax Math here. We're working on our book, Math Test Success. Today is chapter 12, Polynomials. The whole point of this book, Math Test Success, is for you to do the very best you can on any standardized math exam. It is a 25-chapter book available free online. Just go to the link. And then there's a video for every chapter, so I'll be there every step of the way with you, and we're going to work through it together. If you don't have the downloaded book, or if you don't have the book at all, make sure you have a notebook and pencil in front of you. You want to kind of watch these videos interactively. So you want to take some notes, fill in the ideas. You always want to pause the video and do the problems before I do them. Unpause the video and see how you're doing. All right, with all that said, let's go ahead and get started on chapter 12, Polynomials. A polynomial is a many-termed expression. It is an algebraic expression, and the algebra part just means it's going to have a variable x in it. It consists of both variables and coefficients, and there are a few different parts we'll talk about on polynomials. So this is an example of a polynomial here. The term would be 3x squared. That term is made up of two different parts. The coefficient, the 3 in the front, and the x, the variable itself. You could refer to the degree of the polynomial by the highest exponent. So 3x squared plus 2x minus 5. The highest exponent in here is a 2, so this is a second degree polynomial. Again, we have another polynomial here. It doesn't really matter if the variable is x or y or a or b. It is an unknown, and that's why we call it a variable. 4y to the third minus 7y plus 1. This is a third degree polynomial because it is y to the third. There is no squared term in there, which it could have, but the highest exponent is its degree. Down here, we don't have an exponent on that, so it is a 1. So this is 5x to the first. You don't really have to write that 1 in, and that's why this is a first degree. And then this one right here, remember from a previous chapter, anything to the 0 exponent is always equal to 1. So this is 8x to the 0. X to the 0 is 1. 1 times 8 is still 8. So this is a 0 degree polynomial. Okay, we got quite a few sections inside of this chapter, how to add and subtract polynomials. These are really common problems on any ASVAB mathematical knowledge and arithmetic reasoning style tests. It's actually a big part of the introduction to algebra is combining similar terms to see if you understand how to do those operations and what they really mean. So our first example right here is we have a polynomial to the second degree polynomial plus another second degree polynomial. One of the key things to always look for is what this symbol is right here. The quickest way to get tricked on these is not to distribute that symbol through the whole quantity. So this one's positive. It's going to be a little bit easier. I am just going to rewrite this. I have 2x squared plus 3x minus 4. Positive times a positive is plus an x squared. Positive times a negative is negative 5x plus 7. Now, what I'm going to do there is I'm going to combine similar terms. Right? I'm going to put all my apples in an apple basket, all my oranges in an orange basket. So what I'm saying here is I have 2 of these x squareds. I have 2 of these x squareds plus 1 more of these x squareds to give me 3 total x squared. We're really going to build on this idea a lot through the rest of this book. Then after I look at my second degree, I'm looking at just x's. I have 3 x's minus 5 x's. So I have 3 of these things minus 5 of those things to give me negative 2 of those. Negative 4 plus 7 is plus 3. So what I did first is I distributed through that parentheses. I grouped or combined similar terms. I guess those two things are pretty similar. Okay, the next one, number 2. This one example is a little trickier because I have to distribute that negative through that whole quantity. And this, again, is really one of the most ways they catch you, especially on the ASVAB. I've seen this problem 100 times. And then if it's multiple choice, one of the answers will be if you forgot to distribute that negative. So then on this example right here, I'm just rewriting the first third degree polynomial, 5y to the third minus 2y plus 6 minus y to the third minus times a positive minus 4y minus times a negative, negative times a negative, positive, plus 2. From there, I'm combining similar terms. I have 5y to the third minus one of these things. So that gives me 4 of those things, 4y to the third. Negative 2y minus 4y. So I got negative 2 of these y's minus 4 more of them. Negative 6y plus 6 plus 2 plus 8. So that's my solution there. Okay, go ahead and pause that video right now and go ahead and try the example here. And then also maybe while you could unpause the video and watch how I go through it, just double check, and then we'll work through some of these practice problems. So here I have 4x squared minus 2x squared gives me 2x squared. Then I have negative 7x minus 3x is negative 10x. Then here's the tricky one. 3 minus negative 1. 3 minus negative 1 is 3 plus 1, or 4. Okay, down on these practice problems right here, the notation on the computer font's a little bit different. This is the equation editor, and this is just saying right here, this is just saying 3x to the power of 2. This to the power of only applies to that x. Minus 2x plus 1. And then same thing here, plus an x squared plus a 4x, positive, negative, minus a 5. It's a little change in notation there. They mean the exact same thing. 3x to the squared is like that 4x squared there. Okay, again, pause the video, do these practice problems. 3x squared plus 1x squared is 4x squared. Negative 2x plus 4x is 2x. 1 minus 5, negative 4. Okay, let me scroll up here a little bit to number 2. Hopefully this notation isn't throwing you off too much. 5y to the third minus 2y to the third is going to give me 3y to the third. 1y minus, that's going to make it positive. Y plus 3y is 4y. Negative 6 minus 2 is negative 8. Now let's skip 3 and jump down to number 4. 4 is going to be trickier because I've got to remember that negative. 6b to the third degree polynomial, 6b to the third minus 3b to the third. Well, I got these b to the third, right? I got 6 of them minus 3 of them leaves me with 3b to the third. Negative 2b minus 5b, negative 7b, 9 minus 4, 9, no, wrong, right? 9 minus negative 4, negative, negative makes it positive. So that's the same as 9 plus 4, or 13. Hopefully you got those same answers as me. If not, probably do a few more practice problems before we move on to multiplying polynomials. Okay, so example 1 on multiplying polynomials is you have a monomial, a single term, times a double term, right? So there are 2 terms in here, but a single term outside. This is the idea of distribution. You got to distribute that 3x through the whole quantity. So you got to do 3x times 2x, and then 3x times 5. 3x times 2x, a lot different than adding them, right? Because I got to multiply the 3 by the 2 and the x by the x. So that 3x times 2x gives me 6x squared. And then I do 3x times 5, which is 15x. The reverse of multiplying polynomials would be factoring out the common term. That's the reverse operation of this. So if I were to factor out the common term, I would look in here to see what was common in both. A 3 would go in there and a 3 would go in there. Pull that 3 out front. An x would go in there and an x would go in there. So I could pull a 3x out front. All right, we're not going too quick here. Pause the video, do some thinking, practice problems, taking notes. This one right here is kind of a classic algebra problem. The mnemonic device that a lot of people use to remember this, multiplying a binomial times a binomial, is the FOIL method. FOIL is just an acronym, F-O-I-L, and it is saying multiply the first term, the outer term, the inner term, and then the last term. That's what FOIL stands for. What that means is multiply the first term of each binomial, x times x. X times x is going to give me x squared. And really, just like the previous section, let me differentiate between multiplication and addition. X plus x is saying I got 1x, plus another one is 2x. I got 2 of them. X times x is saying a box is x by x. So the area of that box is x squared. Addition, subtraction is on that one-dimensional number line. Multiplication, division is you're in 2 axes, x and y, and you're multiplying building area. Okay, first term is x squared. The second term after that is the outers. So the outers are these two, x times -3, -3x. The inners, pink, the inners are these two, 2x, and then the last are the last terms of each binomial. So 2 times -3, -6. So first thing I've done, multiplying a binomial by a binomial, is I use the FOIL method. I multiplied my first terms, my outer terms, my inner terms, and my last terms. Gave me those 4 terms there. Now that I have those 4 terms, I combine similar terms. -3x plus 2x is -1x. This is different than that. They are different terms. They cannot be combined. So my final answer is x squared minus x minus 6. Guaranteed, you'll see a lot of this foiling on any arithmetic reasoning, mathematical knowledge. It'll show itself in a lot of different places, as well as any intro to algebra course and standardized math exam. We got some practice problems down here, but let me just reiterate again here. Number 1, a monomial through a quantity, you'll see that. A binomial, you'll see that for sure. Binomial times a binomial, like that. And then this is a trinomial. This is a lot less likely. You're not going to see this too often. This right here, you're going to take the first term and multiply it all the way through every value. So I have x times x squared is x to the third. X times -2x is -2x squared. X times 3 is 3x. After you've done that, then you're going to multiply the second term all the way through. Then we're going to combine similar terms. You could see this for sure, but not as frequently as a binomial times a binomial. Okay, second term through, plus 1x squared. 1 times -2x, -2x. 1 times 3, 3. Now that I've distributed that binomial through that trinomial, I combine similar terms. Here's a x squared, here's an x squared. -2 of these plus 1 of these is -1 of them. This one right here, there's no other x cubed term, so I just put that one by itself. Then my x's, I got 3x minus 2x is 1x. And then the only single number I have is 3. So it is a third degree polynomial. All right, that wasn't an easy one. All right, pause the video right here. Do a few of these practice problems. Unpause the video, watch how I do them. Right here I have just a single term times a binomial. I get 2x squared minus 8x. After that, I have a binomial times a binomial. So I'm going to first term it, y squared. Outer term it, negative 5. Inner term it, 3y. So I got negative 5y plus 3y. Negative 2y minus 15. Then lastly, I have a squared here. I'm going to have to multiply this first term through all of them to get a to the third. A times negative a squared plus a. After I've done that, then I'm going to get the second term all the way through. 2 times a squared is 2a squared. 2 times negative a, negative 2a. Whoops, started writing too quick. Negative 2a. See here, we got 2a squared minus 2a plus 2. Combining similar terms, I have a to the third. I like to underline them so I don't double count them. Negative a squared and positive 2a squared is 1a squared. A and negative 2a is negative a plus 2. Again, this is a third degree polynomial as a solution. All right, let's keep moving along. I know we got a lot of stuff here. Here we're kind of going the opposite direction, the inverse function of, now we're factoring out common terms. So here's our first factor. It is a binomial, 2 terms, second degree. And now I need to pull out the greatest common factor, GCF, greatest common factor. What number will go into this and this? Well, the largest number that'll go into both 6 and 9 is a 3. And then I need to pull out a greatest common factor of the variable term. This is x squared and x, so the greatest common factor that'll go into both of them is an x. So that means the 3 and the x together give me a 3x. So I'm going to pull a 3x out. So I pull a 3x out of 6x squared, right? And that's going to leave me with a 2x. And I pull a 3x out of 9x, leaving me with a 3. Let me double check that, right? So I factored out the common terms. The reverse of that is distributing, like we did with a monomial times a binomial. 3x times 2x is equal to 6x squared. 3x times 3 is 9x. So I could see with distribution, this answer is what I started with. It is my check to make sure I factored it correctly. All right, on number 2 here, I have a trinomial because there are 3 terms, and it is a third degree. So I'm looking for a number that's going to go into 10, 15, and 5. Only number that'll go into those, greatest common factor is going to be a 5, so I'm going to pull out 5 out. And then of the y to the third, y squared, and y, the largest number that'll go in there is just a single y, so I'm pulling a 5y out. I pull 5 out of that 10, leaving me with a 2. I pull y out of that, leaving me with a y squared. Remember, you might need to go back and review the chapter on exponents, but the way I multiply these is I add those exponents together. Then now I'm working on that negative 15y squared. I pull a 5 out of that, leaving me with a negative 3. Pull a y out of this, leaving me with a y. And I pull a 5y out of this. It doesn't leave me with 0, it leaves me with a 1. Again, the check on this is to distribute 10y to the third minus 15y squared plus 5y. All right, I know if you're still here, you're doing great. I know it's hard going back and relearning this math, but it'll pay big dividends. Okay, go ahead, pause the video, do these problems, unpause the video. Number 1, 4x squared plus 8x. Common term in here is a 2x. I pull that out front. 2x out of this is going to leave me with a 2 and an x. Pull a 2x out of here, it's going to leave me with a 4. Double check, distribution, 4x squared plus 8x. Y squared minus 25, that's actually a tricky one. Y squared minus 25, we didn't talk about pulling these. This works out to be a perfect square, meaning that this is a squared term and this is a squared term. Y times y is y. 5 times 5 is 25. And there's a negative in the front here. So this is kind of a special case. Factors of y squared are y and y. Factors of 25 are a 5 and a 5. One has to be positive, one negative to give me that negative. The check is a FOIL. Y squared plus 5y minus 5y, that middle term drops out, minus 25. All right, here, number 3, we have an x squared plus 7x plus 10. So I'm going to have to factor that into the factors of x squared, which are only an x and an x. And then now I'm looking for the factors of 10, like a 10 and a 1, or a 5 and a 2, or a 2 and a 5, to give me a 7. I can see right here, these two together add up to 7. So they're going to have to add to 7, but multiply to 10. To get both of them, for this to be positive, they either both have to be positive or both negative. But this is a 7x, so they both have to be positive. Check on that as FOIL, the reverse operation. X squared first, outer plus 2x plus inner 5x. 2x plus 5x gives me that 7x plus 10. So I could see I factored that one correctly. Again, this is like the essence of algebra. There's a ton of information here. I'm going pretty quick. It's only one chapter. Hopefully you've had a little bit of this before, and this is bringing those pieces together. Okay, on this one right here, I'm going to factor it as well. The only factors of a 3 are a 3 and a 1. Only factors of x squared are an x and an x. Factors of 3 are also only a 3 and a 1. But somehow, I got to get these to give me a 10 in the middle. But I already have a 3 here. So actually, let me change those colors. So I factor this 3 to a 3 and a 1. I could see that 3 has to be coupled with this 3 to give me a 9 plus a 1 to give me that 10. So 3x squared plus 10x plus 3. Let's double check this. 3x squared, that works, plus 1x plus 9x gives me 10x plus 3. So they both have to be positive there. Factoring's hard. You know, in school, you spend a ton of time working on those. Okay, I guess I snuck that difference. All right, whoops, let me scoot this down a little bit. So section 12.4, we're looking at difference of squares. That was at y squared minus 25. It's giving me a chance to talk a little bit more about it. So the difference of square patterns is one thing squared minus the other thing squared. Usually, ideally, a perfect square, so it works out to be a whole number or an integer, like x squared or 16. If it is a squared minus b squared, the answer is a plus b times a minus b. And we're still doing that FOIL thing, right? First, a squared plus ab minus ab. Those things cancel each other out, minus b squared, and that's why there's no middle term in these polynomials. So if I have x squared minus 16, hopefully, you do enough of these, you'll recognize this. Perfect square, negative in the middle. It has to be equal to something times something. These have to be x's. These have to be 4's. This is positive. This is negative, giving me x squared plus 4x minus 4x. Middle term drops out. minus 16. Same thing on this one. I have 4y squared minus 9. 4y squared is a perfect square of 2y and 2y. 9 is a perfect square of 3 and 3. So this gives me 2y plus 3, 2y minus 3. I feel like this video is getting a little bit long. I know you're probably getting tired out here. Pause the video, do these couple of problems, unpause, watch how I do them. 49x squared, factors of that are a 7x and a 7x. Factors of 64 are an 8 and an 8. It is a perfect square because there's a negative symbol in between. So it has to be one negative, one positive. And again, that thing right there is 49x squared minus 64. Double check. 49x squared minus 56x plus 56x, bada bing, gone, minus 64. 25y to the fourth will be 5y squared, and another same thing, 5y squared. Factors of 1 are only 1 and a 1, perfect square, one positive, one negative. Different signs, get that middle term to drop out. Okay, factoring polynomials and trinomials. Okay, so this is similar to some of those practice problems I did up above. This is kind of another little review of how to factor. Factoring is a reverse of distribution or multiplying polynomials. So I'm looking for the factors of x squared. So that is only going to be an x and an x. Then I'm looking for the factors of 6 that are going to add to 5 somehow. That could either be a 6 and a 1 or a 3 and a 2. A 6 and a 1 could give me a 5 because I could do 6 minus 1 and get 5. But that means one of them would have to be negative, and there are no negatives. So it has to be a 3 and a 2. This 6 is positive, so either both have to be positive or both negative. So what I'm doing here is I got the reverse of this is to FOIL it out. So that gives me x squared plus 3x plus 2x. That's the 5x plus 6. All right, let's take a look at this example here. 2x squared plus 7x plus 3. Only factors of 2x squared are a 2x and an x. Only factors of 3 are a 3 and a 1. Somehow I got to get a 7 out of that. 3 and a 1 won't give me a 7, but I have that 2. So if I could couple that 2 and that 3 together to give me a 6, 6 plus 1 will give me that 7. So I can put that 3 there, a 1 there. They are all positive, so these are all positive. The check is to FOIL this thing out. 2x squared, outer, plus 6x, inner, plus 1x, last, plus 3, combining similar terms, 2x squared plus 7x plus 3. All right, here's some practice problems here. Pause the video, unpause the video, and watch how I do this. This is really like, this video might work out. Hopefully it'll be under an hour, but it is like an hour-long algebra class, so you might want to break this video in a couple sit-downs. Factors of x, pause it, go ahead and do it, I'll do it. X and x give me the x squared. Factors of 8 to give me a 2 is only going to be a 4 and a 2. Either one of them is negative, so it could either be a negative 4 and a positive 2, or a reverse to give me a negative 8. Ready for this? This one has to be the negative, and I know that because as I reverse my operations and FOIL it out, I want a negative 2x. So this gives me an x squared minus 4x plus 2x. So this is equal x squared minus 4x plus 2x, inner, outer. minus 8. When I combine these two, negative 4x plus 2x, that gives me a negative 2x minus 8. So again, FOIL is the reverse operation of factoring. Okay, number 2, only factors of 3y squared are 3y and a y. Factors of an 8 are 8 and a 1. I don't see that giving me a 10 with that 3. A 4 and a 2. A 4 and a 2 might work because that 2 and 3 give me a 6. 6 and 4 give me the 10. So that means that 2 has to be coupled with that 3 and the 4 right there. Every sign's positive, so these are positive. Let me just double check this. 3y squared plus 4y plus 6y is 10y plus 8. Whew, a lot of stuff going on here. But you could see why this is important for an entry-level position, why it's on every entry exam, is you got to have pretty good number sense, right? You got to split these things into its factors, run permutations in your head. You got to do a fair bit of figuring in your head to figure these out. And that's why so many standardized exams require this. You're never going to be driving a tank and somebody's going to say, solve 3y squared plus 10y plus 8. But the ideas of solving problems logically is what you'll spend the rest of your life doing. And that's why so many people put so much weight into this math. Okay, 2a squared minus 7a plus 6. Only factors of 2a squared are 2a and an a. Factors of 6, well, it could be a 6 and a 1, but I don't see a 7 out of that. So I think it's going to be a 3 and a 2. If I couple that right there, that's going to give me a 4 and a 3. 4 and a 3 is going to give me that 7. So the 2 goes here, 3 here. To get that 6, they're either both negative or both positive, right? This is going to give me a plus 6. So now I have 2a squared minus 3a minus 4a gives me that negative 7a plus 6. All right, here we are on our chapter test of polynomials. Hopefully you're still here with me. If you are here and you've been doing these problems, you probably made some gigantic steps forward in your math education. Pause the video, go ahead and work through this test, unpause the video and watch how I do it. All right, here we go. Actually, I'll just do this with the first one, rewrite it. This is the same thing as 7x squared minus 3x plus 2 plus 2x squared. So this is x to the power of 2 plus 5x minus 8. It's not too tricky because it's a plus sign, but on the next one, you got to remember distribute that negative through the quantity. Now that I've done that, I'm going to combine similar terms. 7x squared and 2x squared is a 9x squared. Negative 3x plus 5x is 2x. And then lastly, I have my 2 and my negative 8 to give me negative 6. Okay, number 2, I have 9y to the third minus 3y to the third. That's going to give me 6y to the third. Negative 4y minus 2y, negative 6y. 6 minus negative, that's a plus. So that's plus 7. Plus 7 ain't my finest handwriting there. Okay, number 3, a squared minus 4a squared is going to give me negative 2a squared. Negative 2a squared. Eight a minus the negative is plus, so that's going to give me 9a. Negative 5 minus 3, negative 8. Here we are with addition and subtraction. Let me move this up to number 4 here a little bit. And then now we got to distribute that 4 through that whole quantity. 4x times 3x squared is going to give me 12. X times x squared is x to the third, right? What I'm saying is x is really x to the 1 times x squared. bases are the same, x, and I add my exponents, x to the third. Part of the reason why math is also hard, it is so dependent on the previous unit. So if you kind of forgot this about exponents, you can't really move on. You make a lot of mistakes. So go back and rewatch that chapter. So that's that right there. 4x times negative, that's going to give me negative 8x times x, x squared. 4x times 1 is 4x. Number 5 right here. Binomial, binomial. I have to FOIL it out. Y squared minus 7y plus 2y minus 5y. That's combined, minus 14. Trinomial right here. I'm going to multiply this 2a through the whole thing. Then I'm going to multiply that 1 through the whole thing. 2a times a squared is 2a to the third. 2a times negative 3a is negative 6a squared. 2a times 4 is 8a. Then the second part of it, I'm multiplying that 1 through the quantity to get plus a squared minus 3a plus 4. Now I have to combine similar terms. There's only one a to the third. Then after that, I have an a squared and an a squared. Negative 6a squared plus a squared, negative 5a squared. 8a minus 3a is 5a plus 4. All right, number 7. Hopefully you're holding strong here. Factor. So that means I got to pull out that common term. What is common in 12 and 18? A 4, a 3, a 6. 6 is the largest one, so I'm going to pull a 6 out. What is common in x to the third and x squared and x squared? So I'm pulling a 6x squared out, leaving me with a 2x. Let me double check that. 12x to the third. In the 18 part of things here, I pull a negative 6x out of there. That leaves me with a negative 3. That's going to give me the negative 18. X squared, well, I pulled that out, so that's it. Again, the double check here is distribution 12x to the third minus 18x squared. That's where I started. Right, we're going forwards with factoring and backwards with distribution. They're inverse operations. Looking at this right here, I got a 5, and a 5, so I'm pulling that 5 out. Y4, Y3, Y2. That's the largest one, the greatest common factor. I pull 5y squared out of that, leaving me with a y squared. 5y out of that, 2y. 5y out of that, negative 3. Just double check that really quick. 5y to the fourth, 10y to the third, minus 15y squared. Hopefully I recognize this as a perfect square of x and 7. That's going to give me x minus 7, x plus 7. Perfect square, x squared minus 7x plus 7x drops out, minus 49. Another perfect square right here, 3a and 3a. 16 is a 4 and a 4. One positive, one negative. 9a squared plus 12a minus 12a, boom, disappears, minus 16. If you're still here, you're doing great. Answer keys are down below in the book. It's the last one. Congratulations for working so hard, sticking it out all the way to here. I know it's hard, I do. But the more you work, the better you're going to do on that exam. Okay, with that said, I have x squared plus 8x plus 15. Only factors of x squared are an x and an x. We're coming into the close of one of the hardest chapters, so get ready for the close here. Factors of 15 are a 15 and a 1. No way to get an 8 with that. A 5 and a 3. Oh, 5 plus 3 is that 8. 5 times 3 is that 15. So it's got to be a 5 and a 3. No surprise, my pen's even getting tired. So that's a 5 and a 3. They are both positive, so everything's positive. Double check it. X squared plus 5x plus 3x, 8x plus 15. There it is. Well done. Thank you for sticking with me here. I understand the heavy lift, but I feel like we're doing it together. This might be a video you might want to watch a second time. There's just so much algebra in here. You know, we're talking about polynomials, binomials, factoring, distribution. There's just a lot of pieces in play here. The more you work at it, the better you get. That's just how it works. You know why these seem so easy when I do them? Because I've been doing them a long time. I've been doing a lot of practice. And they just come a little easier for me because I've been practicing so much. So if you want them to come a little quicker, you got to practice. Okay, thank you.